Hello everyone, welcome to today's class. We'll start with a new chapter known as PNC. The full name is Permutation and Combination. Okay, let's understand first of all the word permutation and combination. Okay. Permutation means arrangement. If the question is asking for number of permutation, he's asking how many possible arrangements for a given situation can be. Okay. Combination is all about selection. That suppose you are in a class and you are making a D-bomb 5 member. So in that, arrangement doesn't matter, means which people get selected in which order doesn't matter. It's just that the selection matter, that who gets selected or not. So combination is all about selection. Okay. Okay, we'll start with the half part of it. First of all, we'll deal with permutation itself. Now permutation means arrangements. So I'll start with the very basic examples. We'll deal with these questions later. Okay. So in order to do the first topic, we'll start with dash method. Okay. For that, I'll explain this. First of all, there is no such formula for too much doing for this PNC. Effectively, the method of understanding your thought process will make this chapter simpler or tough. If you are good with the thought process, you'll be able to do this. Because see, formulas are there, but they are very much restricted, because the moment question slightly varies, the formula will not be applicable. That's why there are methods, no such thing as formula. Okay, too much formulas as such. All right, first of all, dash method. So I'll give you very one simple example. So suppose you have two balls, red and black. Okay, find possible, sorry, find not possible, find number of arrangements. Okay, so now all the questions will be based on this, how many way you can arrange things. Okay, all right. So you have two balls, suppose. So we are placing this on a table. So what, in which order we can place right first and then black, or we can do black first then red. So there are two such arrangements possible. That's it. Okay. Okay, next let's increase the ball. Three balls, red, black, white. Same question, find the number of arrangements. So now let's place red ball first. Then we have two more balls, black, white, or we can do is reverse, white, black. Okay, if the first position is assigned to red, we have two such combinations. Same way we can do for black also. Black suppose is at the first position, so you have two ball, red, white, or you can rearrange this white, red. Okay, same way white, if the white ball is placed first, then you have two balls left, that is red and black, and they can be placed in two ways. White is first, red, black, or black, red. So effectively now you have 6 possible arrangements. So right now we are doing is counting. Okay, now try to think for the next one. 4 balls, red, black, white, green. Okay, now I think it is pretty much understandable that the number of combinations will be more. Okay, let's first let me just explain you how do you do counting for this. Okay, then I'll give you the method itself. Okay, the idea was that for solving even for 3 balls, we placed one ball first. So let's place one ball first. So red is suppose first. Now you have 3 balls left. You will have black, white, and green, and you already know they can be arranged in 6 different ways. So for red at first position, you have 6 combinations for this. Similarly, for black at first position, red, white, green, you again have 6 combinations. For white at first, you will have 6 combination. For green at first, you will have again 6 combinations. So total 24 combinations, sorry, not combinations, 24 ways or 24 arrangements as such. White, left ball were black, red, green. They can be arranged in 6 ways. And here green, so red, white, black. Again, 6 ways. Total is, add them, 24 possible arrangements for this. Now, if I further increase the ball, you can see it's going to be complicated to write all the cases. Again, it has so much a problem. And the point is, we have to generate a pattern starting with 2 ball, 3 ball, 4 ball. So there has to be some better way. So first of all, now let's solve this with dash method. First of all, how many positions are there? Means effectively, if we are arranging 4 balls, so there are 4 different positions. Okay, in which balls will come. Now we don't know in which place which ball will come. So as such, we'll start from here. We'll start with the first ball, that is red can be here, or black can be here, or green can be here, or white can be here. So we'll write here number of possible options available. So for first position, there are 4 different balls that are available, okay, which can come at this position. Now after writing this 4, means out of these 4 balls, 1 ball will definitely come at this place. We don't know which color, but out of this red, blue, green and white, 1 ball will come. So let's say, for simplicity, let's say white was actually placed here. Okay, it can be anything. So whichever ball is placed, now 3 are left. So for second position, as such, now you will have 3 possible options for the second position. Only 3 balls can come because 1 ball is already placed at the first position. Na? Now again, just remove any 1 ball from this. Now you will have 2 such combinations, that is red, black. So 2 possible options, red and black is there. And again, the moment you write 2 means out of these 2, 1 ball has already come. So 1 ball only left. So that is red. Okay, so for the last one, only 1 possible option. Now what do you do with these numbers? You multiply them. And you can see still the answer is same as 24. Again, it's not important which ball comes at this position. I'm just cutting, I'm removing 1 option for the ball, and it can be anyone. The reason I'm using the last one because it's simpler to write this way. That's it. If you want, you can cross the red one first. Still, effectively at the second position, you will be having only 3 possible options. So basically, we are trying to find the number of possible options for each position and then multiplying them. That's it. That's your dash method. Now, this is not a formula, first of all. Okay. All right. Second thing, one more thing, I mean, regarding this dash. Number of dash will not be always equal to number of objects that is available. It depends on the question itself, that how many positions are there that needs to be filled. Okay, you can have more options and less positions as such. I'll explain that with the example as such. Okay, now pretty much I think you can judge for, let me give you one more example for 5 balls. Okay, 5 balls. Okay, red, green, blue, black, white. Okay, again we are finding the number of arrangements. So again, all the balls are being used. That means there are how many dash? 1, 2, 3, 4, 5. In the first position, red can come, green can come, blue can come, black can come. Okay, I'm writing BL for black, and white can come. So all 5 possible options. So 5. The moment we write 5, any one of the ball will come at this position. So let's say white was used. So now you will have 4 options: red, green, blue, black. Again, 1 will be used. So now you will have red, green, blue. 1 will be used, red, green. 1 will be used, only red will be left. So 5, 4, 3, 2, and 1. Multiply them, that's 120. And the multiplication of this 5, 4, 3, 2, 1 is also called 5 factorial. Okay. Now this is a notation that 5 factorial means multiplication of 5, 4, 3, 2, 1. All the numbers up to 5. All the natural numbers basically. Okay. So n factorial, suppose 6 factorial is there. So 6 into 5, 4, 3, 2, 1. N factorial, multiply n, n minus 1, n minus 2 and up to 1, or multiply all the numbers till n. That's your factorial. Okay. So maybe the option can be given in the form of factorial also. Okay. And now for all the questions we'll be solving, if possible, I'll try to use the factorial notation, because multiply you can always do. Okay. Now let's start the questions. Okay. The first question says, how many 3-digit numbers can be formed using the digits? So see, not always every time the question will be regarding this number of balls. It can be about anything. Okay. So first of all, he's creating a 3-digit number, means we don't know which numbers will come at these positions. So right now, since we are creating 3-digit number, so there are 3 dash. Okay. And now the digits that are being used are 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Any one of the digit can come at this position. Let's say one of the digit was used. So as such, number of options are 5. Remember, the number that we write on top is the number of options. So any one will be used. Now this time I want you to understand that any one can be used. So let's say 5 was used. So I'm removing, sorry, let's say 3 was used. So now you have 1, 2, 4, 5. How many options will left? 4. Okay. So again, 1 will be used. Let's say 5 was used. Now for the next position, how many options are there? 1, 2, and 4. So only 3 options. So it's not necessary that every time it will go till multiplication of 1. It depends on the question. It depends on the number of dash. Multiply them. 5 into 4 into 3. So basically this time we cannot write this as a factorial, because factorial is still multiplication of n natural numbers, or 5, 4, 3, 2, 1. Okay, but 2, 1, 1 is not there, so we'll multiply 5, 4, 60. Sorry, 5, 4, 20, 3, 60. So 60 such numbers. Somehow I have solved the first part. The first part was saying repetition of digit is, sorry, I'm not used this one. I have solved the second one. Repetition of digit is not allowed. What is the meaning of this? Means I'm using each digit only once. Since I've used 3 on this first position, I'm not using it again. So I have solved the second part. Remember that every time we are decreasing the number of options are being decreased. That means any one option is being used. That means repetition is not allowed. So this method right now we are doing is for repetition not allowed. So this was the second part. For first part, as such, I'll have to say, like, you don't have to change the method. All you have to do is slightly change your thinking or the thought process. So what if the digits were being repeated? So again, 3-digit number we are writing. We'll write the options 1, 2, 3, 4, 5. Now one of the number will be used. So as such, there are 5 options. So I'll write 5. But I will not cut 3 this time, because digits repetition is allowed. That means even if 3 is used here, still 3 can be used in the second position also. So for the second position, still 1, 2, 4, 5 is there, and 3 is also available, because the question says that the repetition of the digit is allowed. So there is no point in cutting the number that is being used. Okay. So in the case of repetition being allowed, just write the number of options 1, 2, 3, 4, 5. For second position, again 5 options are there, 1, 2, 3, 4, 5. For the last one also 1, 2, 3, 4, 5. So basically 5 into 5 into 5, which is 125, or 5 raised to power 3. Okay. So just remove or decrease the options if the repetition is not allowed. If the repetition is allowed, the answer will be always in this format: 5 raised to power 3, 7 raised to power 5, 3 raised to power 7, something like this. Okay. Usually. All right. First question done. Let's move to the next one. It's saying how many 3-digit even number can be formed from using digits 1 2 3 4 5 6 if the digit can be repeated. So he's saying that the digit can be repeated and he's creating a 3-digit number. That means we have 3 empty places in which we have to place the numbers. How many options? 1 2 3 4 5 6. So 6 options. But since repetition is allowed, I will not cut any number. So again 1 2 3 4 5 6 is available for second position also. 6 1 2 3 4 5 6 is available. So 6 into 6 into 6, that's 6 raised to power 3 or 216. Okay, simple enough. Repetition allowed, don't cut the numbers, just write the options. Repetition allowed, cut one number at every time. Okay, decrease the number of options. Okay, now we have seen a question type in which balls were used. We have seen a question type in which digits were used. Again, we'll move forward. He's saying how many 4-letter code. Now this time he's using letters. Okay, alphabets basically. So 4-letter code has to be generated. How many he's saying? So we have 4 places, so 4 dash, in which we have to place alphabets or letters. First 10 letters. Okay, so E, J. So from A, B, C, D up to J. Okay, so 10 letters. Doesn't matter as such, but he's saying 10. So as such, for first position, I have A, B, C, D, all 10 options available till J. Okay, so 10 options available for first one, number of options. He's saying if no letter can be repeated, that means repetition is not allowed. That means I have to decrease the option each time. So if suppose J was used or one of the option was used, for the next question you will have 9 option, 1 will be used, you will have 8 option, 1 will be used, you will have 7 options. If you want, I can write this A, B, C, D up to it will be this time I. So one of the option will be used. Let's say I was used, then A, B, C, D, sorry, A, B, C, D, G, H, na? So up to H. So again 1 will be used. Again can be anything. And lastly A, B, C, D up to G. Okay, 7, 9, 8. So 10, 9, 8, 7. Just multiply them, you'll get the answer. That's your answer. Simple as that. Okay. Let's multiply 72, 7, 14, 504. So basically 5040. Okay. I hope it is clear. Okay. Feel free to go through the explanation again. Okay. It could be possible that you might not be able to understand in the first go. If you are able to do that, good enough. And for the upcoming questions, pause the video, try to solve this on your own, and then see my method and see if the options that I'm writing here are matching or not. Accordingly, you'll get more confidence. Since I have done already 3 questions and few examples, should be able to now attempt the questions. If it was offline class, I would have asked you to actually solve the questions. I don't prefer to write the solutions only. Okay. All right. So pause the video, try to solve it on your own, and then again see my solution. I'll explain the question. How many 5-digit telephone numbers can be created? So this time we have to create a 5-digit number. 1 2 3 4 5 5 dash using the digits 0 to 9. Okay, so digits can be used from 0 to 9. Everything can be used if each number starts with 67. Okay, means now this time it is putting a restriction on the question that the first 2 digit has to be 67. That means 6 has to come here, 7 has to come here. As such, for these 2 positions I have only one option, 6 and 7. There is no other thing. Okay, now and the question is still saying that the no digit is repeated more than once. That means repetition not allowed. RNA, we tend to use the short notation. Repetition allowed is RA, repetition not allowed is RNA. Okay, so if I write RNA, that means repetition not allowed. Okay, 6 and 7 being used. Tell me what are the options for these positions. You can have 0 at this position. You can have 1, 2, 3, 4, 5. 6 is already being used. It cannot be used more than once. So I'll not use 6. Same with 7, 8, 9. Count it. 1, 2, 3, 4, 5, 6, 7, 8. 8 options are available. 1 will be used. Let's say 9 was used. Now you will have 7 options. 1 will be used. You'll have 6 options. Okay. 0, 1, 2, 3, 4, 5, 8. 1 will be used. 0, 1, 2, 3, 4, 5. Okay. Multiply them. Get your answer. 8 into 7 into 6. Okay. So 56 into 6, 36, 336. Okay, the point is, if you can generate this correct, then it's all about just basic multiplication. But the point, see, the idea to write these numbers, that's very important. And you don't have to write every time this I'm writing just for your understanding. Once you understand this, you can directly write down, okay, 6 and 7 are being used, so 0 to 9 is 10 numbers. Okay, so you 2 are being used, so 8 options available, then 7 will be available, then 6 will be available. Okay, but if you get confused anytime, do write the options and see for yourself how many options are there. Count it. Don't take any risk. All right, next one. A coin is tossed 3 times. Outcomes are being recorded. How many outcomes are there? I think this one you can answer without even trying, because that's like a grade 9, 10th question. How many outcomes are there? So for 3 coins, 8 outcomes are there. But let's see how PNC helps us to find it. Okay. So as such, one time a dice will be thrown, second time a dice will be thrown, third time a dice will be thrown. What are the options that can come at the first throw of a coin? Okay. Dice, not dice is not thrown, coin is thrown. Okay, so head or tail can come, so 2 options. Again, second time you throw, head and tail can still come. Third time, head and tail can still come. So 2 into 2 into 2, that's 2 raised to power 3, that's 8. I'll generalize this for n number of coins. Okay, so for n number of coins are tossed, so number of outcomes will be it will be, so this time n number of coins is thrown, so 2 2 2 2 2 n times, that is 2 raised to power n. Okay, so you can even judge this on your own, 2 raised to power n. Okay, same with if n number of dices are also thrown, dice or dices are thrown, then number of outcomes will be, dice, one time you throw, 6 will come, 2 times 36, that is 6 raised to power 2, so n times 6 raised to power n. Again, one time dice is thrown, 6, next time 6, next time 6, so 6 6 6 are being multiplied, so 6 raised to power n. Okay, so this much you should know directly, you don't even have to think about this, you should know. Okay, I'll erase this is coming overlapping now. HT. Okay, done. One more question. Now this time he is saying you are given 5 flags of different color. Okay, fine. And he's saying how many different signals can be generated. First of all, signal has to be generated, but if each signal requires 2 flags, so and they are being used one below the other, doesn't matter how they use it. Point is, if we are using 2 flags, that means this itself is a signal, 2 flags. Okay, 5 colors are there, so red, blue, green, white, whatever color combination you can think. Okay. If you want, I can write. So let's take red is there, green, blue, white, and black. So for the two flags and that are being used one below the other, the first flag can be red, green, blue, white, or black. Okay, it's like number of balls, na? Like only two balls were used. This time only flag is being used. So the situation pretty much remains the same. So 5 option. Out of this, one color will be used. Okay, given 5 different colors, na? He's saying 5 different colors are being there. That means one type of color is available for each flag. Okay, means I cannot use a single flag more than once. That means this question is for repetition not allowed. You have to sometimes understand from the question whether the repetition is allowed or not. He's saying 5 different colors flags are there. That means each color flag will be used only once. Okay, for next one you will have then 4 options. So how many signals? 20 such signals can be there: red, green, blue, white. Okay, multiply them. Okay, so far basic is done. Let's extend this concept because see, there is a formula known as NPR, but I don't want to teach that. The reason is it's again very much restricted. This dash method covers the formula for NPR also. I'll tell you the formula, but I'll not use it for solving the questions. Okay. Okay, next one. Let's see. So these are some extra questions for practice. So he's saying how many 3-digit, again 3-digit number are being created. So 3 dash. This time he's using all the digits from 1 to 9. So 0 is not used. Okay. If no digit is being repeated, so repetition not allowed, this time is directly stating. So 1, 2, 3 and up to 9. Anything can be used for the first digit. So 9 options. For the second one, repetition is not allowed. So you'll have 1, 2, 3 up to 8. So 8 options for the second position. And 1 will be used. So 1, 2, 3 up to 7. So 7 options. So 9 into 8 into 7. That's your answer. I'm not multiplying this time. The idea to write this correctly is much more important. Okay. 9, 8 into 7. Okay. Next question. Sorry. Okay. So for this question, the question is saying how many 4-digit numbers are there. So he's not asking us to create it. He's saying how many 4-digit numbers are there. So let's say 4-digit numbers. He's saying how many are there. You can do like this also, like 4-digit numbers are up to 9999, and just remove the all 3 digit up the numbers up to 3 digits, so 999. Okay, so that will come 9000. Okay, that is something basic from your childhood, right? Okay, like the highest number for 4-digit is 999, but it will contain 3 digits also, so just remove the 3-digit numbers, all the numbers up to 3 digits, so 999. Let's see how we can use this PNC in this. He's saying how many 4-digit numbers are there. That means all the digits are allowed. That means you will have all the digits from 0 to 9. Okay. Now just think, for the first position, how many options are there? 0, 1, 2, 3, 4 up to 9. So how many options are there? 10. Now think, is it correct? Do we really have 10 options? Can 0 come at the first position? If a number starts with 0, can I say it will be a 4-digit number this time? No. That means 0 is not allowed for first position. That means as such you will have not 10 options for the first position, you will have only 9 options. Okay, because if the number starts with 0, it will not be a 4-digit number. Now for the second position, there is no restriction. Okay. Oh, the question is saying no digit being repeated. That means this answer is incorrect. Okay, because I was thinking like the question is asking only for 4-digit number. So since the digits are not being repeated, so for this cannot be the answer. So we'll derive this. Now saying repetition is not allowed, that means we have to remove number of options. So now for next position, now think how many options are there? 1, 2, 3, 4 up to 8. So 8 options? No, still wrong. Why? Because now 0 can come. Second position, now 0 is allowed, na? So 0 to 8, actually how many numbers are there? There will be 9 number. So again options again used, so 0 to 7, so 8 options, 1 option will be used, then again 0, 1 and up to 6, so 7 options. Multiply them, that will be your answer. I'll repeat again. For first position, okay, for first position 0 was not allowed. 0 cannot come at first position. So for number of options, you will have digits from 1 to 9. So 9 options. Now one of those digits will be used. Let's say 9 was used or 7 was used, anything can be used. Now how many options will be there? 1 to 8. If 9 was used, 1 to 8 will be there, but now 0 can be used. So from 0 to 8 you will have total 9 options now. Now again 1 will be used. So out of these, like from 0 to 8, any one option will be used. Let's say 8 was used. Now you'll have options from 0 to 7. Okay, so 0 to 7, 8 options are there. Again 7 is being used. Now you'll have option 0 to 6. Okay, so you have to be careful whether 0 can come at the first position or not. And remember, if the question contains the digits from 0 to 7, be very careful. 0 to 9, I mean, not 7, 0 to 9. Then be very careful that whether 0 can come at the first position and not. First thing. Next, that from this digit onwards, now 0 can actually come. At first position it cannot, but from second position or third position or fourth position it can come. Okay. All right. Next is saying how many even 3-digit even number. So now he has put us under the constraint of even numbers also. Okay. He's not asking for 3-digit numbers, he's asking for 3-digit even numbers. So first of all, 3-digit number, so 3 dash, using the digits 1, 2, 3, 4, 5, 6, 7, and no digit is being repeated, so repetition not allowed. Now how do we identify even number? If a number ends with 0, 2, 4, 6, 8, it has to be a even number. That means in order to make sure this is a even number, first of all I have to consider the numbers which can come here, because this will decide whether the number will be even or not. So I'll start filling the options from here first of all. So first we'll put 0 can be used, but 0 is not there as such. Okay, so 0 cannot be used. 2 is there, 4 is there, 6 is there, 8 is not there. So only 3 of these digits. Okay, 2, 4, 6. Even 5 is not there. Nice. So 1, 2, 3, 4, 6, 7. No, 5 is also not there. Okay, so 2, 4, 6. Only these 3 options are available for first this last digit, which will make this even. If any of these numbers come at this position, definitely it will be a even number. So now let's say 6 was used, and now come back to the first digit. Start with the normal question only now. Like we solve from the first digit itself. The reason I solved the last digit first, because to make sure the number was even. Now that it is even, I'll start with the first digit. We'll start with 1, 2. Okay, since 6 was used, so 1 can be used, 2 can be used, 3 can be used, 4 can be used, 6 is already used as such here, so 7. So how many options now? 5 options. Out of those 5, any one will be used. So now you will have 1, 2, 3, 4. So 4 options. So 5 into 4 into 3. So that's 60 such numbers are possible for this 3-digit even number with repetition not allowed. Okay. So even number, what is the idea? Even number ends with 246, 0, 2, 4, 6, 8. And same idea can be for odd number also. Okay. So odd numbers ends with 1, 3, 5, 7, 9. The same question can be formulated for 3-digit odd number also. Okay. All right. Next. Now this time again he is focusing on 4-digit number that can be formed using 1, 2, 3, 4, 5. No repetition, no digit is being repeated, repetition not allowed. First of all, is asking this, and then asking second part, that how many are even. So first part, let's solve it. 4-digit number using the digits 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Any one can come. So 5, then 1, 2, 3, 4. So 4, 1, 2, 3, 3, 1, 2. Okay, 2. Multiply them. 5, 4, 3, 2. That will also be 120. Okay. Second option, he's saying how many of them will be even. Now if 60, 120 are the total number, you might think that half of them should be even, half of them should be odd, but that's not always the case. There's a very specific constraint that out of these numbers, half will be even, half will be odd. But in this case, it will be not. I'll explain you once we'll solve this. Let's solve for even numbers now. For 4-digit numbers are there. Okay, and they have to be even. So we'll start with this position first of all to make them even. Even, now for even, only 2 and 4, if those two numbers come at this position, then only the number will be even. So how many options? 2. Out of this, any one will be used. Let's say 4 was used. Now start with the normal filling of options. 1, 2, 3, 4 is already being used. 5. So 4 options for this. Then 1 will be used, then 3 options, then 1 will be used, 2 options. So 4 3s are 12, 24, 48. Okay. You see, not 60 numbers are odd and 60 are even. The reason is because you can see that digits are 1, 2, 3, 4 and 5. So as such, it has more odd digits, so it will have more odd number and less even numbers. Okay. If the digits were 1, 2, 3, 4, 5, 6, then half of them will be even, half of them will be odd. If you understand, then good enough. If you don't worry. You can solve this, that's much more important. If you can find, if the question asks that how many even numbers are there, you should be able to do this. But remember that for even or odd, make sure you fill this first. Options for the last digit first to make sure it's even or odd. Okay, then one more. Okay, next is like there is a committee of 8 persons. In how many ways we can choose a chairman and a vice chairman, assuming one person cannot hold more than one position. Okay, so as such, if we look at from as such, the question is saying choose. I told you that this is like selection, and for selection we don't use permutation. Somehow this question can be solved with the permutation also, and it can be solved with combinations also. Okay, it's not like that there's only one method restricted. Right now we have to think what will be dash. Should the dash be 8 or should the dash be 2? There are two positions that needs to be filled. This is the chairman, this is the vice chairman. In these, suppose it's like a chair, okay? Assume it like chairman has a chair and vice chairman also has a chair, and there are 8 people that are standing, and they needs to sit at these 2 chair. How many ways we can set them up? So basically now it has become a question of permutation. For selection we'll discuss when I'll discuss the combination part. So right now for chairman there are 8 such persons available. Let's say A, B, C, D, E, F, G, H. These are the 8 persons that were available for chairman. Out of these only one person will become chairman. Let's say, sorry, so how many options as such? 8. Okay, let's say C becomes the chairman. Okay, now for vice chairman, how many persons are left? Because one person cannot hold more than one position. So A, B, C has already become chairman. D, E, F, G, H. So 7 such persons are there, 7 such options are there. Out of this, one will become vice chairman or sit in the vice chairman's chair. So 8, 7, 56 is the answer for this. Okay, it's all about a thought process. Okay, all right. For solving these kinds of questions, they are very simple. You need to understand what is n factorial. I already introduced it before. So n factorial is n into n minus 1 into n minus 2. You have to multiply till you get 3, 2, 1. That's it. Okay. Just for your understanding, let's solve few one. He's saying is 3 factorial plus 4 factorial is 7 factorial. Can we really take factorial common and 4 plus 3 is 7? Let's check. 3 factorial is 3 into 2 into 1, that's 6. 4 factorial is 4 into 3 into 2 into 1, so that's 24. 7 factorial is 7, 6, 5, 4, 3, 2, 1. Till this we already know 24. 24 into 5 is 120, into 6 720, so basically 7 into 720. 7 to the 14, 740, 5040. Okay, so now think, really 3 factorial plus 4 factorial is 7 factorial? No. So remember that basic operations of algebra are not applicable on factorials. Factorial, there is one simple rule: you solve it and then only you can simplify it. Don't take like this factorial as a common factor. Okay, like x plus x square, you take x common, don't take that. Regarding n factorial, I want to explain you something like with an example as such. So property goes like this: n factorial is n into n minus 1 factorial. Understand how this actually works. Okay, like 5 factorial. 5 factorial is 5 into 4 into 3 into 2 into 1. But 4 into 3 into 2 into 1 is what? 4 factorial. So basically I can write 5 factorial as 5 into 4 factorial. 4 factorial I can write 4 into 3 factorial. 7 factorial I can write 7 into 6 factorial. Means any factorial can be broken down into a factorial of less number by just multiplying with the same number. One more thing, it's not like we can break it only once, we can break it more than once also. Suppose 7 factorial was there and I need to break down this in terms of 5 factorial. So I'll write 7 into 6 factorial. Then further break down 6 factorial, 7 into 6 in, I'll write break down 6 factorial as 6 into 5 factorial. Or directly come at this. Whatever factorial you want, you multiply till that number. Like you want 5 factorial, so multiply 7 into 6 and then whatever left, 5 is left, now write down 5 factorial. Like 8, you want suppose 4 factorial. So 8 into 7 into 6 into 5 into, now you get 4, write down 4 factorial. Now the call is yours. If you want to break in multiple steps, you can break, or you can break them directly also. 8 factorial is 8 into 7 into 6 into 5 into, now you want 4 factorial, so write down 4 into factorial. It means 4 factorial basically, not 4 into factorial. Why is that helpful? To solve these kinds of questions. Third question, 8 factorial upon 6 factorial 2 factorial. Now what I told you, you can break a larger factorial into smaller factorial. I can write 8 factorial as 8 into 7 into then 6 factorial. If you want, you can break down in multiple steps. 8 into 7 factorial, then 7 factorial becomes 7 into 6 factorial, and then 6 factorial upon 2 factorial. Now the denominator, since nothing is there, that means they are being multiplied. Okay, 6 factorial cancels. Now you solve it. 8 into 7 upon 2 factorial is 2. Okay, so 56 by 2 that's 28. Oh, I remember one more important thing regarding factorial. 0 factorial is 1, not 0. Okay, do remember these points. N factorial, what's n factorial? N factorial can be broken into n minus 1 factorial, and 0 factorial is 1 factorial. 1 factorial is also 1. 2 factorial is 2 into 1. Okay. Fourth one, it's a special type of problem, and if you solve 2 or 3 problem of this time, I'll tell you one shortcut that works for these questions, and the question will always be in order. 6 into 7, 1 upon 6 factorial plus 1 upon 7 factorial is equal to 1 upon 8 factorial. The numbers will always be in order. Okay, how to solve this? First of all, let's write down the question. 1 upon 6 factorial. One method is literally calculate 6 factorial, 7 factorial, 8 factorial. Now pretty much I think you know 7 factorial was already 5040, 8 factorial will be even more. And now taking LCM and everything, it will become very much complicated. So that let's do it smartly. Okay, how do we solve this smartly? What you do is always break larger factorial. Larger factorial is 7 factorial and 8 factorial into the smaller one. Smallest is 6 factorial. So let's break everything in terms of 6 factorial. 6 factorial is as it is. 7 can be written as 7 into 6 factorial. 8 factorial can be written as 8 into 7 into 6 factorial. What is the benefit? We can take 6 factorial. It's a number, na? So we can take it common in the denominator also. Not necessarily that it has to be taken in common in numerator. So basically we are taking 1 by 6 factorial common. So if we take 1 by 6 factorial common, what is left? 1 plus 1 upon 7 is equal to x upon 8 into 7 into 6 factorial. Both sides are being multiplied by 6 factorial. We can cancel 6 factorial. This is the benefit. Now solve this. You get 8 by 7 is equal to x into 8 into 7. 7 also cancels. X is 8 square or 64. And now the shortcut for this particular kind of question, that answer is always this number's square. Always. Okay, I'll give you one example as a question. Just apply the shortcut and solve it. The question goes like this. 1 upon 9 factorial plus 1 upon 10 factorial is equal to x upon 11 factorial. So answer directly now you know. Answer is square of the number that is below x, that's 121. As straightforward as it can be. Solve this as an practice question. See if you can get 121 using the same method, and then learn the shortcut also for this particular kind of question. Okay, if you can recall, good enough. If you can't, should be able to solve it through basics. Okay, all right, that covers the part for today. We have understood dash method so far. There are more methods for arrangements that we'll talk about in the next class. Okay, so revise these questions, go through it, and for this particular chapter I'll recommend like you practice different kinds of question, because the question are based on language. Not too much mathematics is going on, Not too much writing part is required, your thought is required. So do practice extra questions also for this. Not only like the questions that I have discussed are sufficient. No. The more questions you do, the more understanding you'll be able to develop, because the moment you start solving your own questions is the moment you actually learn it. All right, that's it for today. See you in the next class. Good day, everyone. Bye.